I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken a test question based on quadratic equations. I'm calling it Test 2. It is second set of questions. Now these questions have actually come in past test papers, and therefore there is high probability of getting the same in your test also. Now this question is based on optimization. Problem here is a rectangular shelter is to be made using a rectangular sheet that is 5 meter wide and 2 meter long. What value of x will maximize the volume of shelter? So as you can see in the diagram, here is that rectangular sheet 5 meter by 2 meters and it's folded x meters from each side and then bend to form a shelter. We need to maximize the volume. So what should be the value of x? That is what the question is asking for. So let's try to see the volume which we obtain after folding and making the shelter. So from the diagram, it's very clear that if I remove x and x from the ends, in that case, this dimension here remaining will be how much? Well, we have reduced 2x, right? So this dimension will be 5 minus 2x. You get the idea? Which is same as the width. So that width is 5 minus 2x. And the height of the shelter, which is seen here, will be x. And therefore, the volume will be product of 5 minus 2x times x times 2, correct? So as I have explained you, the volume V will be product of 5 minus 2x, the width of the shelter, length is 2, and the height is x. So that becomes the volume of this shelter. We can rearrange this formula, taking minus outside from here so that we can write this as 2x minus 5 times 2x. Well, that clearly gives us two zeros. So if I have to sketch a parabola in this situation, what do I get? I get a 0 at 0 and at 5 by 2. So I get a parabola like this, correct? So where the zeros are at the origin at 5 by 2 and the center point will give us the maximum, right? So that is a 0 and this is the other 0 at 5 by 2. Get the idea? So the maximum is midway between them. So if there are two zeros, let me write down here. So it has zeros at x equals 2. This one is 5 by 2, right? And this one is at 0. So the axis will be right in the center. So axis will be 0 plus 5 by 2, and then you half it, right? So we get this as 5 by 4. Substituting this value of 5 by 4 in the volume, we'll get the maximum volume, right? So let me now substitute the values obtained to get the volume. We have volume as minus 2 times 5 by 4, take away 5 times 2 times 5 by 4, which is equal to minus of minus 5 by 2 times 5 by 2, correct? Minus and minus makes it plus, and we get this as 25 by 4. So that in meters square will be the volume, right? You get the idea? So that is what our answer is going to be. You can divide and write the decimal value also. 4 goes 6 times. 4 times 6 is 24. 10 means 2. And then 20 means 5. 6.25 meter cube, meter cube will be the volume of this particular shelter, the maximum volume. You get the idea? So we say what value of x will maximize the volume. We really are not interested in the volume, but we were only interested in the maximum value of x to maximize, right? So the axis gives you that answer, right? So the answer will be the value of x which maximizes is x equals to 5 by 4 meters, right? Or you can say 1.25 meters. So from each side, we have to take 1.25 meters to get a maximum volume. So the answer actually is that the value of x will be 1.25 meter. However, it has been extended to also find the volume. Right? So that is how you will be doing this question. I hope the concept is absolutely clear. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.